Hello students. So let's start with the problems on areas related to circles. The first exercise, the first question. The radii of two circles are 19 centimeter and 9 centimeter. So there are two circles. So let's take the first circle radius as R1, which is 19 centimeter, and let's take the other circle radius as R2, which is 9 centimeter. Find the radius of the circle. Okay, we have to find radius of another circle. Let's take it as R3. R3 should be found. Okay, so find the radius of the circle which has circumference, okay, equal to the sum of circumference of two circles. Let me pictorially represent it. Let's say there is a circle, okay, R1 of radius R1, that is 19 centimeter, and let's say there is another circle, okay, whose radius is R2. Okay, now we have to find another circle. Okay, we have to find the radius of a circle. Let's say radius is R3. Now this circle is in such a way that if you add the circumference of this circle and this circle, you will get the circumference of the third circle. Let's say C1 is the circumference of first circle and C2 is the circumference of second circle, and let's say C3 is the circumference of the third circle. So according to the question, what they have given us is C3 is equal to C1 plus C2. If you add the circumference of the first and the second, you will get the circumference of the third circle. That is what is given in the question. So let's write, let's C1 comma C2 and C3 be the circumference of the three circles. Okay, so C1 is a circle. C1 is the circumference of the circle whose radius is R1. Okay, C2 is the circumference of the circle whose radius is R2. C3 is the circumference of the circle whose radius is R3. Now we know that circumference is given by 2 pi r. So since this is third circle, 2 pi instead of r, we have to use R3, isn't it? So for C1, 2 pi R1. For C2, 2 pi R2. Now, if you observe the RHS, you can take 2 pi as common, isn't it? So what is left out? R1 plus R2 is left out. So 2 pi gets cancelled. So let's do it the other way. Okay, this 2 pi is in multiplication, right? 2 pi into R3. If you send it that side, it will become division. R3 is equal to 2 pi into R1 plus R2 divided by 2 pi. So 2 pi and 2 pi gets cancelled. So instead of doing this step directly, if you observe 2 pi and R3 are in product and 2 pi and this are in product, so therefore you can directly cancel this and this. Okay, 2 pi and 2 pi. So therefore we are left with R3 is equal to R1 plus R2. So what is R1? R1 is 19 and R2 is 9. So 19 plus 9 is 28. Therefore R3 is the radius of the third circle is 28 centimeter. So what they've asked us is only the radius. Therefore just we have found just the radius. Okay. So let's get into the next question, the second one. In the second question, the radii of two circles are 8 centimeter and 6 centimeter. Again, there are two circles. So let's say the first circle radius is R1, okay, which is 8 centimeter. And let's say there is another circle R2, which is 6 centimeter. We have to find the radius of the third circle. That is what we have to find. Now, let's say the first circle, okay, whose radius is R1. And let's say there is another circle whose radius is R2. And we have to find the radius of the other circle, which is R3. Now what they've given us is the area of the circle, the third circle, is equal to the sum of area of the first and the second. So let's say A1 is the area of the first circle, A2 is the area of the second circle, A3 is the area of the third circle. So what they've given in the question is A3, that is the area of the third circle, is actually equal to area of the first circle plus area of the second circle. Okay, so let A1 comma A2 comma A3 be the areas of the circles, be the areas of three circles. So A3, what is A3? Area of the third circle. Area is given by the formula pi r square. So here we'll be taking it as pi r3 square. So here it is pi r1 square, and here it is pi r2 square. Now again, if you observe the RHS, you can take pi as common. Okay. Now, and one more important thing is, in this chapter throughout, before substituting the values of the radius or whatever the values, before we substitute, we should always try to find the common factors, or we should try to take common. Okay. If you observe in the RHS, pi is common. Okay. Now, most of the problems we'll try to take common. Okay. Whichever is common, we'll try take it out and we'll proceed. Okay. So that the problem will become much easier. So r1 square plus r2 square. So again, pi and pi gets cancelled. So we are left with r3 square is equal to r1 square plus r2 square. So r3 square is equal to r1 is 8 square plus 6 square. So r3 square is equal to 8 square is 64 and 6 square is 36. Therefore, let me do it here. R3 square is equal to 100. So therefore, R3 is, actually we have to take plus or minus square root of 100, but radius is always positive, isn't it? So let's take only the positive. So square root of 100, square root of 100 is 10. So therefore, R3, the radius of the third circle will be 10 centimeters. So let's get into the next question. So in the next question, we have got a figure which depicts an archery target marked with its 5 scoring regions. You can see there is a white color region, black color region, blue color region, red color region, and gold color region. It doesn't seem to be gold, so let's shade it in the gold color, or let's take yellow itself. Let's take this yellow to be the gold one. Okay, now it seems good, isn't it? So we have got gold color, red region, black region, and white region. Okay. Now, the diameter of the region representing the gold score, okay, that is the circle which is inside, okay, that is 21 centimeter, and each of the other bands is 10.5 centimeter width. That is, if you take this white color itself from here to here, okay, this width, okay, what they've given is 10.5 each width. Okay, let me take another color. Let me use red. Okay, this width, as you can see, this width is also 10.5. This width is also 10.5, and this width, let me use different. This width is also 10.5. Each width, okay, the band width, okay, is 10.5. Okay. Now, find the area of the each of the 5 scoring regions. So we have to find the area of each of the scoring regions. Okay. So let's shade this again. Okay. Yeah. First, let's find the area of the gold region. Okay. Here we have to find area of the gold region, area of the red region, area of the blue region, area of the black region, area of the white region. These are the things that we have to find. So first, let's write down the given thing. Okay. So let R1 be the radius of, or let's write it like this, R1 comma R2. There are totally how many circles? 1, 2, 3, 4, 5, isn't it? 5 circles. So we have 5 radius. Let R1 comma R2 comma R3 comma R4 and R5 be the radii of, be the radius of first comma second comma third comma fourth and fifth circles respectively. That is, first circle radius is R1, second circle radius is R2, and so on. Okay, respectively. Now from the question, from the data, the diameter of the gold region, that is the diameter of the first circle, that is equal to 21 centimeters, which implies radius will become what? Half of it, isn't it? So it becomes 10.5 centimeters. That is R1. Now let's find R2. R2 is the radius of the second circle. Let me draw it separately. See, this inner circle is the gold one and the outer circle is the red region, isn't it? Here we have got red. Now the radius of this circle, let me point the center. So the radius here is let me draw it big so that it will be easy to understand. Let's say this is the gold region, and let's say this is the red region. Okay, now I've just taken the gold region and the red region. Okay, now the radius of the gold region is 10.5, and this width is also 10.5. Okay, from the question it is 10.5. So what will be the radius of the bigger circle? As you can see from the figure, okay, O to P is the radius, right? OP is the radius. If you observe, OA is the radius of the gold circle, that is inner circle. OP is the radius of the bigger circle. So if you add 10.5 and 10.5, you get 21. Okay, therefore 21 centimeter is R2. Now what will be R3? Let's take another circle outside, that is blue region. Okay, outside this blue region. Okay, now this is 10.5, this is 10.5. Again this width, let's take this point as Q. Okay, and again this width is 10.5. So if you add all this, O to Q is the radius, right? If you add all this 10.5, you get the radius. So 10.5 plus 10.5 is 21. 21 plus 10.5 is 31.5 centimeter. That is R3. Again, what is R4? R4, radius of the fourth circle. Now, this was gold region, this was red region, this was blue region. On top of it, we have got black, right? Again, let me draw it like this. See, I'm just drawing a rough diagram. Please don't mind it. Okay, I know this doesn't look like a circle. Now again, this width is how much? 10.5, isn't it? So let's take this as R. So O to R is the radius, isn't it, of the fourth circle. So O to R, that is the radius of the fourth circle. So if you add all the 10.5, that is 4 10.5, you get the radius of the fourth circle, which will become 42 centimeter. Okay, again for the fifth one, obviously again you have to add 10.5, isn't it? So that's the logic. So for each circle, if you want to find the radius, you'll be adding 10.5. So R5 will become 42 plus 10.5. That will become 52.5 centimeters. So these are the radius of the respective circles. R1 is 21 centimeter, R1 is 10.5, R2 is 21, and so on. Okay. So we have got radius of all the circles. Now, if you want to find the area of the gold region, okay, if you want to find the area of the gold region, we have to simply find the area of the inner circle, isn't it? So area of the gold region is equal to area of gold region. That is simply the area of the inner circle. So that is pi into R square, but inner circle, that first circle radius is R1. So R1 square. So pi, see, until and unless they mention pi as 3.14, we are not supposed to use it as 3.14. If they give it as 3.14, you're going to use it. Otherwise, we'll take the value of pi as 22/7. Remember that. We always take the value of pi as 22/7. But if they have given the value of pi as 3.14 or whatever, we're going to use that. Okay. So here R1 is 10.5 the whole square. Okay. Now 22/7. Okay. Into 10.5, the whole square can be written as what? 10.5 into 10.5. And remember one thing, in this area chapter or mensuration chapter or volume chapter, any chapters, please do not multiply the values. Okay, always try to cancel. The values will be in such a way that it gets cancelled. Okay, here also if you observe, you can cancel. 7 1s are 7, 7 1s are 7. What is carry? 3 is carry. So it becomes 35, isn't it? It becomes 35. So 7 5s are 35. The decimal point as it is. Okay. Now what is left out? 22 into 1.5 into 10.5. Okay. This is what it is left out. Okay. So 22 into 1.5 into 10.5. Let me make it a bit easy. See, what you can do is, you can actually use distributive property, okay, which you have learned in lower classes. See, 1.5, can I write it as 1 plus 0.5? Isn't it? 1.5 can be written as 1 plus 0.5. See, you can directly multiply. You know the normal multiplication, right? Do the multiplication. Again, whatever answer you get, again, you have to multiply by 10.5. You can use that, or you can make it a bit easy. What you can do is 22 into 1.5 can be written as 22. I mean, 1.5 can be written as 1 plus 0.5. Now let's multiply. What is distributive property? This 22 should be multiplied for both, isn't it? So 22 into 1 is 22 plus 22 into 0.5. See, 0.5 is basically half, 1 by 2. Okay. So if you multiply any number by 0.5, it reduces to half of it. So meaning, for example, if you multiply 22 into 0.5, it becomes half of it, 11. Okay. If you multiply 100 into 0.5, it becomes half. 100 becomes half, that is 50. If you multiply 20 into 0.5, it becomes 10. Okay. Whatever you multiply with 0.5, that number will become half of it. So 22 into 0.5 is how much? 11. So 22 plus 11 is how much? 33. So if you multiply, see, this is very easy, right? So if you multiply 22 and 3.5, sorry, 22 and 1.5, if you multiply, how much do you get? You will get it as 33. Now 33 into 10.5. Again, same logic. 33 into 10.5 can be written as 10 plus 0.5, isn't it? 33 into 10 is 330. 33 into 0.5. So 33 into 0.5, what should you do? Take the half of 33. What is half of 33? It is 16.5. So add this, how much do you get? 330 plus 16 will become 346.5. Okay, this is much easier. Okay, you don't feel very hectic. Okay, so the area becomes 346.5 centimeter square. Okay, everything is given in centimeter, so it becomes centimeter square. This is regarding the area of the gold region. Now what we'll do is, let's find the area of the red region. Let me solve it here itself. Okay, now area of red region. Area of red region. What will be the formula? Now look at the figure. The figure is like this. The gold color is here inside, and outside you got red. Okay, let me shade the red region like this. You want only this region. This is like the circular ring, right? Let me show the circular ring also once again. Okay, do you remember this? This is called a circular ring, right? What is the formula to find the area of the circular ring? Pi into capital R square minus small r square, where capital R is the radius of the outer circle, small r is the radius of the inner circle. Same concept. Okay, if you have not understood it, let me do it again. Here, let's find the area of the bigger circle. When you find the area of the bigger circle, you'll be finding all this area, whatever I've shaded, you'll find it. Okay, but you need only the red region, right? You don't need this gold color. So what you're going to do is, you're going to subtract the gold color. Okay, when you subtract it, okay, you will get only the red region, as you can see. So from, you will find the area of the bigger circle, then you will subtract the inside circle, that is a smaller circle. Okay, so basically red region is a circular ring. Okay, so what will be the formula? Pi, the outer radius is R2, isn't it? Square minus R1 square. So what is pi? Pi is 22 by 7. Now R2 is 21 square minus R1 is 10.5 square. Now please do not find 21 square and 10.5 square then subtract it. That is bit lengthier. Instead, what you can do is, you can use the formula a square minus b square is a plus b into a minus b. You can use this formula. Okay, so that's what we are going to use now. So 22 by 7. Here a is 21 and b is 10.5. So a plus b into a minus b, 21 minus 10.5. Okay, so what do you get? 22 by 7. 21 plus 10.5 is 31.5 into 21 minus 10.5 is 10.5, isn't it? 10.5. And you can cancel, as I told you, 7 ones are 7, 7 fours are 28. Okay, 3 carry, it becomes 35, 7 fives are 35. So point as it is. Okay, now what you got is 22 into 4.5 into 10.5. Again, we'll use the distributive law, which will make the problem very easy. 4.5 can be written as 4 plus 0.5, isn't it? So 22 into 4 is 88. 4 to 8, 4 to 8. 22 into 0.5 is 11. So 88 into 11 becomes what? 99. So if you multiply the first two numbers, you get 99 into 10.5. Again, the same logic, 99 into 10.5. This 10.5 can be written as 10 plus 0.5. So 99 into 10 is 990. Again, 99 into 0.5. So whenever you multiply 0.5 with any number, that number becomes half of it. So what is half of 99? It is 49.5, isn't it? Add this. So if you add it, how much you get? 9, sorry, it's not 9,000, 1,039.5, isn't it? So that will be the answer. So the final answer will be, the calculation must be shown in working column, 1,039.5 centimeter square. See, if you had multiplied 22 into 4.5, then with 10.5, it would have taken much longer time. So using this techniques, okay, makes the problem bit easy. Okay. Now, we should also find area of the blue region. So let's find that. Okay. Let's insert space. Okay. Now let's find the area of blue region. Third one, area of blue region. Area of blue region. Okay. Now look at the figure. Okay. If you want to find the area of the blue region, okay, it is again, see, let's take, this is the third circle, the second circle, okay, and inside we have got another circle. Let's forget that for time being. So this is blue region, and we have got this inside one is red plus gold, isn't it? So let me draw that also. This is gold and this is red. Okay, red plus gold is the area of the second circle, isn't it? So now we want only the shaded part. Again, what is the formula that we are going to use? Same formula. The outer circle area minus inner circle area. Okay, because if you concentrate, forget about the gold region. Okay, inside you got a circle. Let's forget it. If you find the area of the third circle, you get this complete part, isn't it? If you find the, let me show it here itself. If you find the area of the third circle, let me use this color. Okay, let me use a different one. Okay, let me undo it. See, when you, let me take a different one. Okay, see, when you find area of the third circle, you get this complete thing, right? Okay, you get this complete thing. Whatever I've shaded in brown, that is the area of the third circle. In that, what is not required, if you remember, you don't need the thing that was in red and blue, right? The red and gold, sorry. So same logic, okay, whatever we applied, okay, so we are going to use the same logic. That is area of the bigger circle minus area of the smaller circle. Okay, still if you have not understood, let me do it again. Okay, it's very simple. This is the blue region which I'm shading it. How does it look like? It looks like a circular ring. So we're going to use circular ring formula. Okay, I know there is a circle inside. Forget about that circle. Okay, just concentrate on the second circle and the third circle. So the region that I've shaded is what? The region that I've shaded is circular ring. So here we are going to use circular ring. For each area, we are going to use circular ring itself, except the first one, the gold region. We are going to use circular ring formula. So pi, the third circle radius, R3 square minus R2 square. So what is pi value? 22 by 7. What is R3 value? It is 31.5. If you remember, minus R2 is 21. Okay, square. Let me show the value of R3 and R2. So as you remember, R3 is 31.5, R2 is 21. Okay, so let's find this. 22 by 7. Okay, again a square minus b square. So a plus b, a minus b. Okay, so 22 by 7, a plus b, a minus b. So 31.5 plus 21 becomes 52.5, isn't it? 31.5 plus 21, yes, 52.5. Okay, into 31.5 minus 21 will become 10.5. So what you got is 22 by 7 into 52.5 into 10.5, isn't it? So again, cancellation. 7 ones are 7, 7 sevens are 49, 3 carry, it becomes 35, 7 fives are 35, a decimal point here. So what you got is 22 into 7.5 into 10.5, isn't it? Again, the same logic. 22, 7.5 can witness 7 plus 0.5. So 22 into 7, 7 twos are 14, 1 carry, 7 twos are 14, 14 plus 1 is 15. So it becomes 154 plus 22 into 0.5 is 11. 154 plus 11 will become 165, isn't it? So 165 into, again, we have to do 10 into 10.5. We can write it as 10 plus 0.5. So 1650. If you multiply these two, 165 into 0.5 becomes how much? 82.5, isn't it? 82.5. 0.0 added. So 2, 8 plus 5, 13. 1 carry. So 6 plus 1, 7. So it will become 1732. So the area is 17. Let me scroll it a bit down. So the area is 1732.5 centimeters square. Okay. Now similarly, let's find the area of, after blue it's black region. So let's find the area of the black region. Let's find the area of black region. Area of black region. Again, black region is also a circular ring. Okay. So now it is fourth circle minus the third circle. So pi r4 square minus r3 square. Okay. So I have done enough problems here. So you can try out this. Now for the last one, area of the white region. Again, the same formula. Area of the white region will be the same formula. That is pi, the fifth one, r5 square minus r4 square. So solve this and find the answer. So let's get into the next problem. The next problem is a very, very important problem. So listen carefully. So the wheels of a car are of diameter 80 centimeter. So we have got a wheel. Okay. Let me represent it using a circle. Let's say this is wheel. Okay. What is the diameter? The diameter is given as 80 centimeter. Okay. Which means the radius will become 40 centimeter, isn't it? They have given the diameter as 80. So let me, diameter is 80 centimeter. Okay. Which implies radius is 40 centimeter. The radius of the circular wheel is 40 centimeter. Okay. How many complete revolution does each wheel make in 10 minutes when the car is traveling at the speed of 66 km per hour? A very interesting question. See, we have to find how many times will the tire or the wheel rotate. Okay. If the car is going at a speed of 66 km per hour in 10 minutes. Okay. It's very interesting, isn't it? In 10 minutes, the car would have rotated many times, isn't it? We have to find how many times. That's what we have to find. Okay. Now, remember, in 10 minutes, let's find what is the distance traveled by the car, or what is the distance covered by the wheel. Okay. Covered by the car in the sense covered by the wheel. Okay. Why should we find the distance? Because we know that distance covered by a circular wheel in n rotations or n revolutions, that is given by the formula n into 2 pi r. So remember, we have got the radius of the circle. We want this n value. If we have this distance covered, then I can easily find it, isn't it? So here n value should be found, but we don't know what is the distance covered. But distance is also given by this formula, right? Speed into time. Okay. Now, but there is one small thing that I can say is, here the speed is in kilometer per hour, but the time is in minutes. So we have to make sure everything is in minutes or everything is in hour. So I'll convert minutes into hours. Okay. So the speed will become speed is what? 66 kilometer per hour. Okay, so 66 into 10 minutes. So 1 hour is 60 minutes, right? So, or I can tell it like this: 60 minutes is 1 hour, 10 minutes is how many hour? Cross multiply. 10 into 1 is 10 divided by 60. So 0 0 gets cancelled. It is 1 by 6 hours. Okay, so it will become 1 by 6. So 6 ones are 6, 6 ones are 6 ones are. So therefore the distance covered is 11 kilometer. Okay, we'll convert this into meters. So if you convert this into meter, it will become 11 kilometer is 11,000 meters, isn't it? Why did I convert it into meters? Because the radius is in centimeter. This radius I can easily convert it into meters. How do I convert it into meters? Just divide by 100. If you divide by 100, it becomes 0.4, isn't it? So 0.4 meters. So everything should be in the same SI unit, isn't it? If you want to solve, everything should be in the same SI unit. Let me do this stuff again. So listen carefully. We know that distance is given by this formula, speed into time. The speed is given as 66 kilometer per hour. Now, time is given in minutes. So let's convert it into hour. How do we convert? Simply divide by 60. That's it. Okay. So 0 0 gets cancelled. 6 ones are 6, 11s are. So it is 11 kilometer. If you convert that 11 kilometer into meter, it becomes 11,000 meter. Okay. So we got to know the distance covered. The distance covered is 11,000. Let me write it here. Distance covered. Distance covered is 11,000 meters. That is equal to n into 2. Pi is 22 by 7 and r is 0.4. Okay, we need n, we don't need the 7 which is in the denominator, so let's send it the other side. So 11,000 into 7, okay, is equal to n into 2 into 22 into 0.4. Do not multiply, okay, because the numbers will always be in such a way that they get cancelled. Okay, so 11,000 into 7, we need n, we don't need the other numbers, so they are in multiplication. If you get this side, it will become division. So 22 into 0.4, that will be equal to n. Okay, now you can cancel. 11 2s are 11, 1s are 0 0 0 as it is. Now 2 1s are 2, 500s are 2 1s are 2, 250s are. So what we have got here is 250 into 7 divided by 0.4. Okay, that is equal to n. Now remember, or let's multiply the numerator. Okay, or you can also divide it by 4. Okay, or let's multiply the numerator. 7 zeros are 0, 7 5s are 35, 3 carry, 7 2s are 14, 14 plus 3 is 1750. Okay, once again, I guess we have done a small mistake, because now yeah, you can divide it. Yes, you can actually divide by 4 itself, or let's multiply the numerator. So if you multiply the numerator, 7 zeros are 0, 7 5s are 35, 3 carry, 7 2s are 14 plus 3 is 17, 1750 by 0.4 equal to n. Okay, so if you shift this decimal, okay, if you remove the decimal, we have to place 1 0 in the numerator, so it will become 17500 divided by 4 equal to n. It actually divisible by 4. 4 ones are 4, 4 fours are 16, 1 carried becomes 15, 4 threes are 12, 3 carried becomes 30, 4 sevens are 28, 2 gets carried, 4 fives are. So therefore n is 4375. Okay, the number of revolutions or number of rotations is 4375. And remember, this n value will not come as a decimal. Okay, it will always be a natural number. So if you're getting the value as decimal, then you might have done some mistake. Okay, so let's recall what we have done. See, for any problem based on the number of revolutions, we are going to use this formula. Distance covered is equal to n into 2 pi r. So here we didn't know distance covered, but speed was given. So using that speed and time, we found distance covered. Once we found distance covered, we substituted in the formula and we have easily calculated the value of n. So let's get into the next problem. So tick the correct answer in the following and justify your choice. If the perimeter and the area of the circle are numerically equal, then what is the radius of the circle? Perimeter of the circle is simply the circumference. So circumference is 2 pi r. If that is equal to the area of the circle, what is the radius? This is the question. Okay, so 2 pi r is equal to pi r square. So pi and pi gets cancelled. Okay, one time r and one time r gets cancelled, or you can also do it the other way. Okay, actually 2 pi r is equal to pi r square. This is given according to the question. Perimeter is equal to area. Okay, so according to the question, 2 pi r is equal to pi r square. Pi and pi gets cancelled, and 2r is equal to r square is the left out thing, isn't it? Now, remember here we are trying to find r. Please do not cancel 1r and 1r, which I did earlier. Okay, that is actually wrong because we are trying to find r. And what is the highest power of r? It is 2, which means we'll be getting two values. Okay, two values of r. If you remember quadratic equation, whenever the highest power is 2, okay, if the degree is 2, we'll get two values, isn't it? Two roots. So similarly here, we'll have two values of r. How do we get it? It's very simple. Let's take 2r to the other side. So 0 equals r square minus 2r, or you can write the other way. R square minus 2r is equal to 0. Here what you can do is you can take r common. So you will be left with r minus 2 is equal to 0. If product of two things is 0, then individually r is equal to 0 or r minus 2 is equal to 0. That is, if you remember, if a into b is equal to 0, either a should be 0 or b should be 0. If you are multiplying two numbers and you're getting the answer as 0, then obviously one should be 0, right? Among them, out of two, any one should be 0. The same logic. This is like a and this is like b. You're multiplying and you're getting the answer as 0. Therefore, either a should be 0 or b should be 0. That is, either r should be 0 or r minus 2 should be 0. So if r minus 2 is 0, if you send minus 2 to the other side, r will become 2. R cannot be 0, right? That is not possible. If r is 0, then it is not a circle at all. Remember, if r is 0, then it becomes, if radius 0, then it becomes a point. It doesn't becomes a circle. Okay, so this is not possible. Okay, so therefore the correct value of r is 2 units. Okay, so the option A is the correct answer. Okay, students, so we have completed the first exercise. In the next video, we'll start with the second exercise. Thank you, students.